ఈ పర్టికులర్ ప్లేస్లో మన కెమెరా వ్యూ అన్నది
ఇదేంటికి వేరే ఐడియా
ఇది కూడా ఏంటంటే అప్పుడు వస్తుంది
మినిట్స్లో ఉన్నా అది క్లోజ్ చేయి అది వీడియో వచ్చి
వీడియో ఆఫ్ చేసినారా
అదే క్లోజ్ చూడండి సార్ లాగౌట్ చేస్తే వస్తుంది
ఓబిఎస్ అంత రికార్డింగ్ అవుతుంది
దీంట్లో ఓబిఎస్ లేదు ఓబిఎస్ లేదు దీంట్లో
ప్రొజెక్టర్ దీన్ని బెస్ట్ లైట్ అవును కంటిన్యూ
పెట్టుకుని చూద్దాం ఇన్స్టాల్ అయితే మారిపోతుంది లైన్లో వేసుకోండి అమ్మా ఇది క్లోజ్ చేసి ఇదే ఇవ్వండి సార్ ఇదే ఇవ్వండి
ల్యాప్టాప్ది
కాదు వెబ్ క్యామ్ది రాలేదు ఎనేబుల్ చేయండి సార్ అంటే పూర్తి డ్రైవర్స్ అవ్వలేదు కదా కమ్యూనికేషన్స్ పెట్టాలి హెడ్ఫోన్స్ స్పీకర్స్ సార్ మైక్రోఫోన్ కావాలి కదా మనం మాట్లాడేది వినపడాలంటే మైక్రోఫోన్ మైక్రోఫోన్ మార్పు స్పీకర్స్ ఎలాగో మామూలు హెడ్ఫోన్స్ మైక్రోఫోన్ అదే కమ్యూనికేషన్ స్పీకర్స్ దగ్గర హెడ్ఫోన్స్ పెట్టండి
పైన సార్
హెడ్ఫోన్స్ సౌండ్ పెంచాలి ఓకే
Sai, you can start the session.
Okay, sir.
మరీ హైట్ ఎక్కువైనట్లేదు
హైట్ లేకపోతే
Hmm?
Good morning, everyone. Hope my voice is clearly audible. Respected principals, sir, governors, sir, teachers, and all my dear students, good morning to one and all present. Thank you all for making it at this early for us. This is Nikhil, currently pursuing my Bachelor's in Technology from Amrita University. I'm here to discuss about a very important topic. One has to master in technological world. This is as a part of Student Social Responsibility Program initiated by our university. Without any further delay, let's dive into the topic. I shall start this session assuming that you have no idea about coding and you are listening to this for the first time. Okay? So basically, what is coding and how does it work? So coding is basically the process of writing instructions that tell the computer what to do. Computer programmers write instructions using a specific computer language, and all these instructions enable computers to run complex programs. So to explain or to put it in simple terms, coding is basically the process of giving computers the instructions in a particular language that the computer will understand. Just like how we all communicate in English or Telugu or Hindi or Malayalam, computer also has a language which it understands. To give you an overview, we shall try to explain it. Explain it as a language which in turn is converted into a binary language. We must always remember that a computer only understands binary, nothing else. So to make it clear, this follows a sequence. Firstly, you should enter the command in a particular language, like a particular computer language. This gets compiled and then it gets executed. As I said, there are a few computer languages which we type. This is compiled and then converted into a binary language, that is the computer. Computer understandable language. So talk about computer languages as we progress, but now let's first look at a compiler. As you can see, there's a fruit and a juicer. Say the body is craving for a juice and you're a person who doesn't like to have the raw food. So what you do, you basically process the fruit using a juicer, which gives you the juice as the output. Similarly, we can draw an analogy between juicer and a compiler. So basically, a compiler can be interpreted as a processor, which processes the commands entrusted in a particular language into the binary form. That is the basic duty of the compiler. So, what does a compiler do? A compiler compiles the commands which were entered in the computer in a particular computer language into the binary. So now the binary language. As I said, a computer can only understand binary language. I hope all of you must be knowing what binary language is. It's a language which consists of only ones and zeros. So as I said, a computer can only understand ones and zeros. It is similar to a true or false question or an on or off. In general, you can see, on is denoted with 1, that is true, and off is denoted with a 0. For example, even if you ask your computer to play a particular song, it doesn't understand your direct command. Rather, it converts everything into the binary form which consists of ones and zeros. So suppose you say that you ask the computer to think that 3 keys. It only understands the binary form. So 2 will be converted into the binary form. And 3 will also be converted into binary form. So you can't keep typing ones and zeros for a command manually. Hence these computer languages have been developed which later gets compiled into the binary form. Just for the key that the computer language is here. So what is the scope of coding? Why must one learn to code? Coding is important to learn because it teaches you important skills such as critical thinking, problem solving, and creativity. It also helps in design and simulation. It is also a skill that is valued in the workforce, say the IT industry. So So firstly we look into K.B.N skills. So this actually helps in the logic building. This at a beginner level can be treated as solving puzzles, and at professional levels make a computer itself solve puzzles. For that we use many algorithms like machine learning algorithms or artificial intelligence algorithms. So this also includes your mathematical skills, and there are of course many other uses apart from just making the computer do it. Then comes the information technology. So information technology, you might have heard this term in the IT industry. So basically information technology is the use of any computers and its software to process the electronic data that's necessary. If I go deeper into this, this would be too heavy for you at this particular level. So let's first see few of the IT firms. I hope you can see the pictures over here. There's YouTube, there's Facebook, there's Wikipedia, there's Microsoft, and all these also come under the IT sector. So next we have the designing and simulation part. We also use many softwares to design and also to simulate. We have MATLAB, which is basically newest form of a calculator. It's not just a simple calculator which you use, but this actually is basically it converts everything in the form of a matrix and does all sorts of calculations. It plots, graphs, it does all of the mathematical stuff as well. Next we have the languages. So yeah, as I said, a programming language it is basically nothing but a language which makes the computer understand it. Using a compiler, the language which we enter gets compiled, and it in turn executes. It converts it into binary form, and the particular command gets executed. So let's see a few of the programming languages now. This is an overview. So this is C language, which is the most common language, and you might have heard this language many times. So what it uses is basically it can handle low-level activities and produce efficient programs. It runs faster, it is portable, or we can also use C code to various other applications like databases, text editors, assemblers, and then we have C++. C++ is basically an extended version of C. It supports the object-oriented programming class. So then we have Java. Java is also an object-oriented programming language. Its main applications lie in the areas of mobile app development, and then IoT and also cloud-based applications. And then we have Python. Python currently tops the list in the job market. It has the maximum applications to do it. So basically Python is easier. Compared to the other languages, this is close to the English language which is generally used. And then Python is also an object-oriented program. And now, since you, and then of course there are not many languages, JavaScript, Ruby and all. Now, what if you want to learn code or you want to practice code? Basically, these days, learning how to code a language is not tough. With the advent of the internet, many courses which once used to be too expensive are now available for free. There are many websites such as Geek for Geeks, Code Courses, HackerRank, and also many other YouTube channels which provide content for free. These also emphasize on competitive code. So this can also be taken up as a hobby too. So furthermore insights will be given by my teammates. Thank you.
Hi everyone, I'm Sasman Guru. I'm pursuing the third year in Electronics and Communications Engineering from Amrita University. So, before we get into the topic, I would like to just ask a question. When do you think you can work more effectively? Is it in a library or Is it in your house or is it in your school? Or which place do you think is more effective? For me, I guess I would like to work in a library where because it's silent. And for the past 2 years, I've been in my home and it's completely noisy because there's construction going on and there's some small scale industries near my home. And this really affects my effectivity, the productivity of my work. So in these cases, the thing which changes, it's the environment. So normally based on the environment, our productivity matters. Even though we're getting an output, even if I'm in the library, I get an output, or if I'm at my home, or if I'm in like the housing place, I still get an output. But the thing that varies is actually the productivity. So I might be more effective when I'm inside and I'm not anything. So similarly, when we're coding, it's better to have a really good environment. I'm not talking about the external factors, I'm also talking about the software factors also. So normally while you're programming the first step, you need to select a perfect environment so that your code is more suitable or your program is more flexible to do. So that's the first topic in the basics of programming. Environments. So when we come to, so normally an effective environment should be having a really good and a cool looking text editor. For example, now in the screen as you can see, there's an image of a text editor, right? Yes, it's from various areas. So what makes this text editor looks really cool, right? I really feel like doing some coding in this text editor. And later I need to have a really good compiler as we did so before. The compiler should be really good and we need to have a really good execution time. So normally like if I'm working on something, I will get an output maybe after 10 days. But it's better if you get an output within less than 1. So same thing, a program can be having a better compiler so that we can have a slow, like a lesser level time. So we can get a more productive and more, let's say, more better output, right? So that's why we are using these environments. Now, like as we told before, we have many coding languages. We have C++, we have C, we have Python. Oh my God, there are so many. So now each languages will be having a certain environment, right? So normally these environments are developed by various languages themselves. So these environments will be having some packages, some updates, which makes its languages more effective. So such environments are called IDEs or integrated development environments. So these environments provide lesser runtimes, they improve your productivity very well, it has better packages, and it offers better options and better security too, and it's more faster. So some examples are Python, Eclipse, Visual Studios. So let me show some IDEs which I work on mostly. So generally I like to use the Visual Studios code as you can see on the screen. This is the IDE which I like to use very much. So this code is actually a text editor. Here we can download extensions related to other languages. It can be C, C++, Python. For now let me show. So now actually I have already downloaded some extensions for Python. So I can download extensions for C++ just by going to extensions folder. Okay. And I can install my C++ folder. And I can download some more things such as the debuggers and everything. So I can code any program language using VS Code. So that's why I prefer to work on this. And let me show you an execution tool. So here I have a program which has some numbers stored. And I'm going to find the square of these numbers and print it in my console. So this I need to just click a play button. But normally if you are working on some other tools or some other platforms, what you must do is you have to have a terminal, you have to go to a particular directory, you have to enter a particular code such as PIP and file name.py, then only you can run it. So here I can just click on press button and okay, I got output here. So I got squares of all numbers present in a, let's say, a box. 1 is 1 is 1, and again 2 we got 4, 3, 9, 5, 25 and so on. So this is the editor which I like to use very much. And let's come to the next topic. Next we have variables and data types. So how many of you are aware of the simplest way? Express to express code. Yeah, what do you think of the X's? Anyone? Anyone know what the X value is? Actually not value. What is X? So normally X is actually a variable. So normally a variable in a sense, it's like let's say it's a random location where I can store some values and after execution I can just remove it. So normally in mathematics we call it as variables, even in programming also it's called variables. So let me just show out more detailed K.B.N over there. Suppose I have three boxes, A, B and C. I'm storing strings in box A. I'm storing some boolean values throughout box in box B. And I'll be storing some numbers in the last box. So now when I'm running a program, I want star value of 35. And I know it's in a variable called C. So what I can do, I can just call C and I can take the value and I can do some execution on it or computations. So upon running some computations, so what I can do, I can take a variable, I can do some computations, and after the execution is done, or after the program is done, I can just remove the data. So the variable is just temporary. So our definition for a variable is it's a temporary address allocated in a RAM so that it can store any data or value. It can be a string, integer, or anything. So normally, what are computations here? So normally in mathematics we have some operations, right? Addition, subtraction, division, multiplication, and all these. We can perform the same operations using Python coding. So here we have, let me just highlight this one. We have plus is for addition, as you know, minus, star is for multiplication. Then we have this bar which is used for division, and we have the percentage symbol which stands in modulus. So modulus is used for finding the remainder. So these are a few other operations which you can use in coding. And you have some other operations such as unity, logical, bitwise, all these are not necessary right now. And now before I go to it, integer, string, boolean. What are these things? So these are actually called data types. So normally every variable happen. So a variable can be an integer, can be a boolean, float, anything. So here the integer is nothing but the numbers such as on decimal numbers. It is 0, 1, 2, 3, minus 1. These are another categories, 700, 600, so on. These are also the integers. And next, even float, decimal points. So such as 2.8, 3.14, minus something like that. All the values are decimals. And next we have is a boolean, on, off, 0, 1, true, false. Only two values can store in a boolean. It can be either true, it can be either false, nothing else, or it can be 0 or 1. So this is a boolean value. And next we have so we can say that hello world is program, even a number can be strings, just one thing or a little one, all these can be strings. But we need to just make sure we have a double apostrophe. So actually, when I talk about it, for example, now maybe most of it can have access to Google, right? So if you have Google account, then definitely you can be having a Google Colab. So in a Colab, it will be encouraging Python codes. So here I wrote a Python code to find I wrote a question over here and drew out me because which is another. So this is Google Colab. Maybe you can just type Colab in your Google Plus and that will clear the website to it. And another editor, online editor, which we are using is New Layer. We will be using it throughout this course. And we will be using Python because it's easier for you to understand. So now, coming to discuss some variables. As I told before, we will store numbers and we will be which companies printing it. So for example, let me call a variable length. This is equal to, I'll say something. Let's say I have some variable length. I take it as now I want to find the area of a rectangle. So what I can do? Computation. Area is equal to, now if I go to length, we all know area of rectangle is length into width. So I can do the same thing. Here, length. Now as I told in arithmetic operations, multiplication is start. Length into width. As I know the length is 10, width is 10. Now I want to print the area. So print. Let me just say. Not print the area. So let me not visualize execution. Okay. Okay, so now first line is then this 10. So what is compared to in a particular country, this one length. And in this length is going to so again, similarly, next, I'm going to find again. So A is equal to 10 into 5. Oh, I'm finished. So this is each operating. Similarly, let's try and a bit complicated. How many know arithmetic progressions? Can you just raise your hands if you know it? Yeah. So can you tell the formula of finding the n term in an arithmetic progression? Anyone before anyone? Okay, so let me just people just keep this. So here is this term and it's diagram and the things will be different. So let me just write the equation here. First we need a variable a. Let's say let me make it a different. Next, what are the variables a, n and p, right? So we already wrote a. Now I need n and p. So n is equal to n dot and let's see now. So here input what improvement it will be taking input from the users. So I can just write a execute program, I can just do any input. So now I have to variable a and now what is the operation presented the formula? It's actually a plus n minus 1 equal to b, right? We have plus, we have minus, and we also have a multiplication. So let's say e is equal to a plus, we have n, we have minus, we have 1, and multiplication symbol. So this is a plus and minus 1 equal to. Now the question has finished. This is the code of prior conversion. Now let me just execute the code. It's asking me to give an input. So let me say a value is taken as 1. Next I'm going to start with p. I mean, they have to find n value as well. Next I want to find the value of p. I mean, actually p let me take it as 2. So we're going to have a difference of 2. So okay. Now as you can see we have variables a is 1 and this and b is 2. Now I'm going to give another variable p and I have to do the execution or execution. And let's go and compute the formula and I got a value of 20. Now I want this value to be printed. So again let's go on this one. Okay, 20. So this is how we can do expressions using Python. Or actually using this online editor. So now I would have to call upon my friend Gaurav in be teaching the conditional and statements.
My name is Gaurav and I'm familiar with expert at Kamatars with Jessica. And as Bharat explained, where we can work using the different types of environments and what are the different variables and data types that are in programming. I just take it and deliver control flow of programming. You can perform operations, you can perform multiplication, division, subtraction, and you can find the remainder when one number is divided by another number. All these operations are specific. So, but how to use this in a practical situation? Like in a practical sense, computer is just a machine. It cannot think for itself. You have to help. You have to give it a particular set of instructions, and then help it think for it. Still follows this instruction. That's it. The most a computer can do is follow the instructions that you give. So How do you give those instructions? To give those instructions, we use something called as conditional statements. And human beings, like if you put your hand in hot water, you'll understand that it's hot and then you'll immediately take it out. Or what are you doing here? If the water is hot, take out your hand, right? Or the room is cold, switch off the AC. Same thing, you're giving these instructions to the computer using conditional statements like if statement and if else statements and all. So, yeah. So conditional statements, expressions or simply conditionals are a piece of programming language that tells the computer to execute certain actions, provided certain conditions are met. For example, there is a flowchart here that shows first the user enters the input and then the user, like the computer already thinks of a number, it randomly generates a number, and if the user input is equal to this generated number, then the user they win in this particular game. So if the user number is not equal to the computer generated number, then it checks if the number is greater or lesser, and then it returns it tells the user if your number is lower case again, your number is higher case again. So this is a particular type of program or a game which you can code in Python using if-else conditions. Conditional statements are used through various programming languages to instruct the computer on the decision to make when given some conditions. These decisions are made if and only if the pre-stated conditions are either true or false, depending on the functions that the programmer has in mind. Now, if you want to execute some conditions, you need to have some operators, right? You need to understand if this is hot, this is cold, or this is greater than. So for that we have operators. So here we have a bunch of operators. The greater than symbol is pretty straightforward. It means greater than. If one number is greater than the other number, execute this. Or less than. Same logic. If this is less than that, do this. And greater than or equal to, less than or equal to. And in programming, there is a duality in equal to signs. So when you have a single equal to between two integers or two variables, not integers. When you have a single equal to between two variables, you are assigning the value of the right variable inside your left variable. But when you have two equal to signs, you are comparing the two variables. You are asking the computer to see if variable 1 is equal to variable 2, and if it is equal, the computer will return 2. So that is how equal to works. And not equal to is also an essential part of programming. So it's just an exclamation mark and equal to symbol. So what it does is it compares variable 1 with variable 2, and if it's not equal to, it returns true, and if it's equal to if those two variables are equal, it returns false. Now let me show you some examples. Let me show you some examples of this code. So, have you ever wondered about your body mass index? Like how your weight and height are in perfect proportion, or are you a little underweight, or are you a little overweight, are you in perfectly healthy condition? So, this is a code that calculates your BMI and tells you what to do based on where you lie in the spectrum. So I just this one can stop setting hands. And so how this code is done. Thanks. So this is the code, and we'll use it. So first we are entering the height, and we have chosen the data type float here. Previously when Smaran was showing an example to you guys was an int here. But here we choose a float because height and weight, those are not integer quantities, right? Your weight can be 55.6, your height can be 167, your 0.9. So we need decimal values for that. That's why we have taken float here, okay? So first, enter your height in centimeters. Let's say my height is somewhere around 172 centimeters. suppose weight is somewhere around 60 kgs. So here you have two variables, height, like we do not have got meters. This is the, I am telling the computer calculate the BMI. BMI is as the weight divided by square, okay, meter square, weight by meter square. So so here we got the BMI as 20.95. Now we need to give the user what you should do based on your BMI. Are you healthy? Are you underweight? Are you overweight? Or are you obese? And if you are underweight, then you will be a lot of food. If your BMI or if your weight is proportionate to your height, then it's pretty good. You should keep that. And then if you are a little overweight, you maybe need to consider going to the gym. And if you are a little to the obese side, then maybe you should exercise and start with the diet. Now, I want you to think what will be the output here. So the BMI was calculated as 20.95. So 20.95 it lies within this region, right? So that means the person's BMI is pretty good. Their weight and height proportions are pretty good. So let's see what the computer does. First, it checks the if statement. Like the BMI, if the BMI is less than or equal to 18.5, but BMI is not less than or less than 18.5, so it skips that statement. It doesn't print here. Now it checks whether the BMI is between 18.5 and 24.9. It is between those values, right? So it goes to the print statement inside this condition, and then it prints that value. Pretty good. Keep it up. So, for example, if I give my height as 1 meter, and maybe I'm just giving my weight as I don't know, maybe 120. That's a very obvious person. Just for the purpose of visualizing. So here we got the BMI 61.224. That is our log, right? It's not even between. It's a lot higher than 29.9. So again, once it checks if it's less than 18.5, no, it skips that statement. It checks if it's between this interval, no. So it skips that statement. Then it checks between this interval. Again, it's not there, so it skips that statement too. So what did we say? If it's not any of these conditions, then you have to exercise the law and it's not really that. So that's what is written here. So that is how if-else conditional statements work. Okay, if you decide a bunch of conditions, you do a few calculations, and you tell the computer what to do if this condition is true or if this condition is false. So these conditional statements they give a nice flow to your program. Like it makes the computer more intuitive, more approachable. And machine learning and artificial intelligence are quite in the boom these days, right? Wherever you go, you are hearing about machine learning and artificial intelligence and how they are the future of everything. But at the programmer's level, machine learning and artificial intelligence, they are nothing but if-else statements and a lot of contracts. And then we never do that. So now that we are done with that. Smart is scientific theory. We look at loops, okay? Smart. So we are done with now the next important thing you need. The next important thing you need when you are programming a code or when you are doing programming in any language is a loop. Because if you want to send a message to a person 5 times, you can type print hi, print hello world 5 times. You can do that 10 times. But what if you wanted to print that statement 1,000 times? You can't just keep on typing print. That would be a lot of work, right? So for that purpose, we have this thing called loops. So the loops are among the most basic and powerful programming concepts. So a loop in a computer program is an instruction that repeats until a specified condition is reached.
in a loop structure, the loop asks a question. If the answer requires action, it is executed. Okay? The same question is asked again and again until no further action is required. Each time the question is asked, it's called an iteration. Okay? So each time the loop runs, it's called an iteration. So there are different types of loops, and for now there are this for loops, there are while loops, and there's also do while loops which are not used that much these days, but they're still viable in the development and other areas of programming. So a for loop is a loop that runs for a set amount of time. So you as a programmer decide how many times my for loop has to run. Okay? And a while loop is a loop that is repeated as long as the expression is true. Again, a while loop is a conditional loop. We give a condition inside the while statement, and as long as the condition is true, the while loop keeps executing the code inside it. If the condition is false, the loop breaks and the code comes out of it. There is also infinite loops which you can run, but generally infinite loops are avoided by programmers because they cause a lot of complexity and they take up a lot of the computer's RAM. So we avoid them. And there's also display loops. All these things we'll focus on later. For now, we'll focus on a for loop and a while loop, and I'll show you how both of them works. I'll share my screen now. This works. So this is a code to print the sum of numbers up to a certain number. So as most of you guys are in the second year or first year, or even if you completed your 10th standard, you should be knowing the formula for sum of numbers up to n number, right? N into n plus 1 by 2. But we don't need a formula to do that inside when you're coding. You just need to enter the number, and you can use a loop to print it, right? To find the sum. So if I say 5, if I have the input as 5, so first I'm declaring a variable called sum as 0, okay? Summation is 0 for now. My value summation is 0. And now I'm starting this for loop. So for I in range, so I starts from 0 and goes up to the number n. So it starts from 0, 1, 2, 3, 4 and 5. And I gave it as n plus 1 here because in Python, a for loop takes this value is there, right? N plus 1. So in Python, a for loop takes the range up to n minus 1. So n plus 1 minus 1, that will give us n, right? N is 5. So let's see how this code executes. The value of summation is 0 right now. So first I is 0. I is 0, so summation equal to summation plus I. Summation is 0 again. Now I will increment. So I will become 1. So I became 1. And 1 is added to our summation variable, it became 1. Again I became 2. And 2 is added to our summation, it became 3. Now I is 3 is added to our summation variable, and it becomes 6. And then I is 4. 4 is added to our summation variable, and it becomes 10. And then I is 5. And 5 is added to our summation variable, and it becomes 15. So since this is the value of sum of numbers up to n equal to 5, the code executes from the loop, and then makes the sum of numbers up to 5 is 15. So this is how you do you use loops. Otherwise, what you would do, you would give a1 equal to 1. And A2 equal to 2, and B equal to 3, A4 equal to 4, A5 equal to 5, and A1 plus A2 plus So if you were not using a loop, you would have to declare 5 different variables and you would have to calculate the sum in this way. Since it's just 5 variables, that's okay. But what if you were calculating the sum of 100 variables or 1000 variables? You can't just keep typing a6 equal to 6 and so on, right? So for those purposes, for repeating a certain condition or for executing a certain code, you use loops. So this is a for loop, and then I will show you why. So I
sorry to interrupt. Sorry, no wait. We can again continue from here from that 10 o'clock.
okay, sorry.
So everyone, we'll take a break now. No? And again we'll continue from 10 o'clock. Thank you.
రండి ఫాస్ట్గా.
Sir, you can continue your section. You can continue, sir.
మీకు అర్థం కావట్లేదు అనుకుంటా ఈ మీటింగ్ మొత్తం రికార్డ్ అవుతుంది అండ్ మీరందరూ కూడా కెమెరా కింద ఉన్నారు. ఎవరి మొత్తం ఏమైనా ఎక్స్ట్రా మాట వచ్చినా ఆ మీటింగ్ జరుగుతున్నంతసేపు ఆ స్క్రీన్ మీద నుంచి దాకా ఏదన్నా తిరిగినా ఎటు తిరిగితే అటు ఇచ్చేస్తాను. చూడండి సీరియస్ గా మనకి పని వస్తే అనుకుంటే జాయిన్ అవ్వండి లేదా నోట్ కూర్చుంటాడు. నోట్ మీద మాట్లాడుతున్నాడు చంపాల్సి చెప్తున్నాను కొలుస్తున్నారు.
రవీంద్ర గారికి ఫోన్ చేసి అతను కంటిన్యూ చేయమని మెసేజ్ పెట్టినాడు. వస్తున్నాను. ఆడియో రావట్లేదు ఏంటో. పిల్లలు వచ్చారండి, అతనికి మెసేజ్ కూడా పెట్టాము, ఫోన్ చేసాము. ఫోన్ అంటే అతను స్టార్ట్ చేశాడు కానీ ఆడియో రావట్లేదని చెప్పడం న్యూస్లో ఉంది. ఇంకా ఎక్కువ రెస్పాండ్ అవ్వట్లేదు.
You are not audible, sir. Hello. Sir, you are not audible.
ఫోన్ చేయించుకోండి.
ఆడియో రావట్లేదు.
మీకు ఇంట్రెస్ట్ కలగట్లేదేమో కానీ మనం కొంతమంది చేత ఒక పని చేయించుకోవాలనుకున్నారు. మీరు ఉన్నారు పొద్దున్న చదవాలంటే చదవరు కదా. సో మనం కంట్రోల్ అనేది ఏం చేస్తే మనం ఏ పని చెప్తే ఆ పని చేస్తాం. కానీ వాళ్ళకి మనం చెప్పాలంటే ఏం చేయాలంటే కోడింగ్ అని కాదు, ఆ భాష అంటే తెలియదు కదా. ఆ భాషలో నువ్వు 2+2 చేయాలంటే 4 చేస్తారు. 2+2 చేయాలంటే ఒక గంట ఆలోచిస్తారు. ఎందుకంటే కొడుకులు తీసుకొని రావు కదా. సో ఇప్పుడు ఏం చేస్తున్నారు అదే అంటే కంప్యూటర్ లాంగ్వేజ్ యూజ్ చేసుకొని వాళ్ళు కంప్యూటర్ పని చెప్తున్నారు, కానీ ఈ పని చేయాలి. సో అది చేస్తుంది. సో ఒక్కొక్కటి చూడండి 1 by 1 స్టెప్ ఏం చెప్తున్నారు, ఇలా చేస్తే ఇలా చెయ్యి అని చెప్తే అది దానికి మనకి రిజల్ట్ ఇస్తా ఉంది. సో 1 by 1 మీరు అర్థం చేసుకుంటా ఉండండి. ఒకవేళ అర్థమైంది రేపు పొద్దున ఇది ఇప్పుడే మనకి తెలుసుకున్నాం అనుకో, మెల్లిగా జాయిన్ అయితే రేపు పొద్దున్న భవిష్యత్తులో సాఫ్ట్వేర్ ఇంజనీర్ అవ్వాలనుకున్నారు. లేదు మీకు ఇంట్రెస్ట్ వచ్చి అదే ప్రాక్టీస్ చేశారు ఇంటి దగ్గర వెళ్ళిన తర్వాత. ఇప్పుడు కాదు, రీఫైన్లు పైన ఎగ్జామ్స్ అయిపోయిన తర్వాత ప్రాక్టీస్ చేశారనుకున్నాను. ఏదో వచ్చిన యాప్ లాంటి తయారు చేస్తే బయట నుంచి ఆడేసింది చూసారా, మరి ఫోటోలో ఒక యాప్ తయారు చేశాడు, ఒక కంపెనీలో కొనుక్కొని అని. అలాగే మెమరీ కోసం కూడా ఎవరు కొట్టుకోవచ్చు. అంటే మీకోసం పక్కనలో కొట్టుకున్నట్టు కాదు. అదే సీరియస్ చూడండి, వాడు ఏ కమాండ్ ఇస్తున్నాడు దానికి ఆన్సర్ ఏమవుతుంది అంటే కంప్యూటర్ ఎలా రిప్లై చేస్తుంది. తను ఏ కమాండ్ ఇస్తున్నాడో దానికి కంప్యూటర్ ఏ విధంగా రిప్లై చేస్తుంది. అది నేర్చుకోండి మెల్లిగా వర్కౌట్. వాళ్ళు ఏదో చెప్తా ఉన్నారు ఆ పర్సంటేజ్ క్యాల్కులేట్ చేయమని. 123% 20 అడిగారు కదా. సో దాన్ని ఎలా క్యాల్కులేట్ చేయాలి అని అన్నప్పుడు మనం క్యాల్కులేట్ చేయాలని ఏం చేస్తాం, ఏం చేయాలి కదా. అదే కంప్యూటర్లో 2 లైన్లు రాస్తాం అనుకో, ఒక పదే ఆన్సర్ చేస్తాను. సో ఆ విధంగా ఒక్కొక్కటి 1 by 1 స్టెప్ వైజ్ నేర్చుకుంటా ఉండండి. సో అప్పుడు ఇంట్రెస్టింగ్గా చూడాలనిపిస్తుంది. ఏదో లేకపోతే వచ్చి ఏ జపాన్ సినిమాలో లేకపోతే చైనా సినిమాలో చూసినట్టు కాకుండా సీరియస్గా దాని వైపు కాన్సన్ట్రేటెడ్గా చూసి ఎవరన్నా మాట్లాడితే మట్టికి తీసుకెళ్ళి బయట వాళ్ళు లైవ్లో చూస్తూ ఉంటారు కదా. ఈ కార్డర్ చక్క ఈ మొత్తం కూడా మోకాళ్ళు ఎత్తుస్తారు. ఏ ఒక్కరు మాట్లాడినా కానీ అయ్యాతో చూసుకొని ఉన్నాడు. ఎక్స్క్యూజ్ సార్ ఈ రుద్రవరం నో ఆడియో ఇస్ క్లియర్ ఫర్ అస్. హలో సో ఆడియో ఈజ్ నాట్ ఆడిబుల్ టు యూ ఆల్సో.
ఎవరు ఈ షబీరు ఆకాశ ఎవరు అదేంటి
ఇద్దరు ఫస్ట్ ఇద్దరు చెప్పు స్కైవే ప్రొఫెషన్ అండి లే మ్యాగ్నెటిక్ ఇంక్లినేషన్ ఏంటి? తెలుసా తెలుసా తెలీదా? మరి ఎందుకు మాట్లాడుతుంది నోటండి? నీకు బాగా చదువుతుంటే కొనుక్కోవచ్చు, చదువు లేదు, చదువు మాత్రం ఉంది. అందరూ అంటే కొనుక్కోవచ్చు అక్షరం మొక్క లేదని మిమ్మల్ని కైమా పెట్టండి నరికేసినా కానీ ఒకటి రాదు, ఒక అక్షరం మొక్క దొరకదు చెత్త వెళ్ళాలని.
రావట్లేదు ఇంకా రావట్లేదు వేరే ఆడియో అంతా వస్తుంది అడ్వర్టైజింగ్ సెట్ నడుస్తున్నారు లేదు కదా మీరు మాట్లాడండి. రావట్లేదు. రావట్లేదు. పిన్ ఒకసారి చెక్ చేసుకోండి స్పీకర్. నేను మాట్లాడితే వినపడుతుంది కదా ఇప్పుడు మీకు. అలాగే మీరు మాట్లాడేసి మాకు రాదు. ఎందుకంటే మంటే నుంచి ఎగ్జామ్స్ సెట్టింగ్స్లోకి వెళ్ళి ఆ ఆడియో వీడియోలో చెక్ చేయండి.
తెలియకుండా చదువు చెప్తున్నా ఎదురా ఏ అంత తిరిగిలేదు ఇంటికాడ రోజులు బట్టి అయ్యా చదువుతుంది ఏం చేస్తున్నా కాళ్ళు రాస్తుంది ఇంటికెళ్ళి ఉందా
ఒకసారి రివైండ్ చేయాలి. No. No. No.
Hello, sir. Hello.
Yeah, it's now audible.
Okay, sir.
Excuse me.
Hello, can you guys hear me? Yes?
Yes, audible now.
Yeah, okay. Thanks. sorry for the technical issue. I'm Vijay. I'm pursuing my bachelor's degree in electronics and communication engineering at Amrita K.B.N. Up to now, we have seen different types of topics in coding, like variables, data types, conditional statements, and loops. Now we are going to discuss some of the emerging technologies. I'm going to tell you about IoT. Have you ever heard about Alexa or Google voice assistant control devices? Like there are some lights and some devices. Right? If you give voice commands to those voice assistants, like Alexa, turn on the lights, it will turn on the light. Or if you say Google, turn on the TV, it will turn on the TV. This kind of technologies come under IoT. Over the past few years, IoT has become one of the most important technologies. Now that we can connect, with the help of IoT, we can connect everyday objects like kitchen appliances like fridge, chimney, or car thermostats, or suppose we can even, with the help of IoT, we can even see the pressure of the air in car tire in our mobile phone. These all transmit with the help of internet. Like there will be an embedded system or a controller near the tire which senses the pressure and it transmits over the internet to a mobile phone. Now let's see an example of a tree or of a plant. A plant requires oxygen, moisture, and nutrients. Right? With the help of this all will be required in the plant. We need to make sure it gets enough light. So how do we do it? There is an embedded system for that also. It can sense the light that is being received by the plant. It can sense the moisture level in the soil, and it transmits to a mobile phone or to any application with the help of internet. Some of the basic things which you see in our everyday life are water level detection, smart house, and car parking, and an IoT based fan. It's like, suppose if you take an example of an IoT based fan. If you take an example of IoT based fan, it will be like go turn on the. No, you don't have to go and turn on the switch every time. You can just give a command through your mobile phone or any voice command through any voice assistants. It makes our life easy, right? And how to learn IoT? Like, can you make your own devices, or how will you make? What technology does it use? Now we can make our own IoT devices with the help of some microcontrollers like Arduino and Node MCU. It has an inbuilt Wi-Fi module in it which can transmit the data which you want to your application. Now my friend Tarun will continue and tell you about more interesting stuff like the artificial intelligence and machine learning in detail. Thank you.
Hello guys, good morning. Am I audible? Okay, let's go into artificial intelligence. It is a science and engineering of making intelligent machines, especially intelligent computer programs. It is related to similar tasks like by using computer to understand the human intelligence. Like the artificial intelligence is accomplished by studying how human brain thinks and how human learns and how he decides and what while trying to solve a problem. So mainly aim of artificial intelligence is to make a mission to mimic a human. So you can see in figure right side. First artificial intelligence and machine learning in the deep learning. So coming to machine learning. Machine learning is a study of a computer algorithm that can
improve automatically through experience by the use of a data. Machine learning is a subset of a broader concept of artificial intelligence under AI, intelligent machines simulate human thinking capabilities and its behavior. And deep learning. It is a subset of a machine learning where artificial neural networks algorithms inspired by human brains learn from large amount of data. Deep learning and the deep learning allows the machine to solve a complex problems even when using a large data set. And next going to computer vision. Computer vision is a field of artificial intelligence that enables computers and the system to derive a meaningful information from the digital image, videos, and the other visual inputs. It can detect the classifying objects, like you can see in the figure here, bottom right. It shows the it's a car and it's a person, it's a traffic lights and a bicycle like that. And we can go into the uses. Okay, coming to object recognition. This is a computer vision the technique for identifying the objects and images or videos. Like it is a key output of a deep learning and machine learning algorithms. When humans look at a photograph or watch a video, we can readily spot people, objects, and the visual details. And the obstacle avoided. Okay, it is a type of a autonomous mobile robot that avoids the collision with unexpected obstacles. Like for example, there is a car with a back camera, right? So it can detect the when a person walks through a back, it can detect the person is in back and it gives some sound to stop going back like that. And analyzing image. Image analyze is a meaningful information from image, mainly from digital image by me. It means like it gives some task can be simple as reading a tags like QR codes. For example, in you can see you have to pay money to buy a shopkeeper. So you can use a QR code by PhonePe, Google Pay or Paytm like that. It is under the image analyze. And also medical field, it is used in various healthcare applications to assist in medical professionals like MRI scanning and cancer detection. And next going to that in our daily life how we artificial intelligence use, like in phones there is in Google Assistant and Siri, we can use them like to make a calls and send a messages and set a reminder. If we want to specific music, then we can ask like Alexa, I want this specific song like that. So it is useful in that. So next my friend Smaran will continue.
So, hello everyone. So now I want to take a couple of biometrics. So before we actually, what's biometrics? So So this is actually a field where biology and engineering both come together and make projects. Okay. So normally, during my +1, +2, I come across people who think that biology and engineering are completely two different streams. But actually, after coming to engineering, I got to know that biology and engineering both can come together to make some really great and novel projects. So in those projects, one field is biometrics. Now you know that our human body has so many amazing and brilliant functions, such as now our blood will flow into our brains and we can actually calculate blood pressure and our neurons, the way we walk, everything can be measured. And all this measured data can be stored, can be given to a device, and the device can actually do some calculations, do some operations, and etc. and give an accurate measurement. For example, now I guess most of the guys are familiar with Fitbit, right? What's like this one? What does it do exactly? Whenever I wear it, whenever I sleep with it, maybe calculate my sleep, or we calculate my heart rate, we can calculate how much exercise I'm doing. All this is done actually by some trainings, and it will measure my pulse, which is actually here, I guess. Somewhere here, it will calculate my pulse over here, and it will be measuring my heartbeat. It can even calculate some of my sleep temperatures and everything. So right now, even this small parts comes under biometrics. So we have some projects or some types of biometrics over here. So one is the authentication level or the fingerprints. I guess now we are in a generation where most of us smartphones come with a fingerprint sensor, right? So we can just unlock our phone using the fingerprint sensor. So now this fingerprint is becoming a new trend, and maybe soon it will get over also. So normally, let me show you one thing. This is a sensor which I'm holding. This is actually a fingerprint sensor. So in this sensor, if we connect this sensor to a laptop, maybe using another, let's say a module, so a USB module, I can just connect these two and connect it to my computer laptop. And so later I can just keep my fingerprint. I can scan my fingerprint with the help of this, and my laptop can actually read it. And after reading, maybe I can do some operations, and maybe I can develop a project where I can actually stop my laptop. I only use my fingerprint like this. So this is one way of using fingerprints. And using one fingerprint is a way of authentication where there are more ways. What do you think we can use for authentication apart from fingerprints? Anyone? Apart from fingerprints, what else can we use in order to get some authentication or to provide security? It's already there in I think Apple's not experience. Yes?
Please slow down your voice. So you are too fluent in English, but the process you are telling is a very speed.
Oh, okay, sir.
Please slow down.
Yes, sir. Okay, so let me just come back here. So, our fingerprint recognition, right? So, when we are using fingerprint recognition, we can use it for security purposes. So, maybe we can connect it to our road sensors, and we can scan our fingerprints, and if your fingerprint matches, because every human will be having their own unique fingerprint set. So maybe we can use that to recognize the person or provide security also. And now we have some other authentication services such as face recognition. Because most of people have unique face features. So we can use face recognition, or there is a retinal scanner where we can scan the eyes of the person in order to get some unique characteristics. So these are some authentication levels for biometrics. And next we have is, let's go for it. Brainwaves. Brainwaves is actually a really interesting topic. Do you know that we have billions of neurons in our mind and throughout the entire body. So these neurons communicate with other neurons with the help of electrochemical pulses. So almost we're generating around, let's say each neuron can generate around 1 microvolts of power or electricity, through which we can communicate with other neurons. So what if we have a chance to collect all this power, or maybe we can read that voltage transfer? Then what we can do, we can extract information from our brain which is going to our hands. So maybe we can use the same information to give it a robot. Means I can control a robot using my brain. This is called a brain-computer interface. I'll show you one interesting video which I found in net, which can really help me in this topic.
technology for decades. It's called brain-computer interface, or BCI.
The field of brain-computer interface relies on the ability of the brain to be able to generate certain types of responses that can then be harnessed by computers to be able to be interpreted by computers.
Dr. Rajesh Rao is a neuroengineer and director of the Center for Sensory Motor Neural Engineering at the University of Washington and is funded by the National Science Foundation. He is developing safe, non-invasive devices that can connect to the brain to accomplish things like control from steady arm. Or become to a computer. Much like how the brain controls muscles, researchers can use new technologies to tap into these signals to control machines.
The understanding of how the brain controls movement led to the development of devices and algorithms that can be implemented on a computer that will recognize these patterns in the activity of brain cells and then correspondingly move an artificial device.
To demonstrate how this technology works, Rao and his team of students use a BCI that allows them to study nonverbal communication. First, the student is fitted with an electroencephalogram, or EEG cap, which is a series of electrodes placed on the scalp to record brain signals. When a question appears on the monitor, the student answers yes or no by looking at one of the flashing lights, which are blinking at different frequencies. When the subject's eyes focus on one of the response lights, the frequency of that specific light is picked up by the visual cortex in the brain and measured by the EEG cap. 12 hertz represents a yes frequency, while a no is at a frequency of 13 hertz.
Now you can see a peach right up to 12 hertz. No is for 12 hertz.
The computer interprets this signal and moves the cursor in the direction of the response. Using an EEG cap isn't the only way to measure brain activity. Some BCIs use a method called electrocorticography. It also records brain activity, but unlike the EEG cap, it is surgically placed directly on the surface of the brain, providing a clear signal and more precise information.
For example, they can imagine moving their hand and we use the computer to extract the patterns that correspond to imagined movement of the hand, compared to, for example, not imagining and just resting.
From there, the computer can distinguish the two types of brain activity: imagining movement and non-imagining movement. Then, use that information to enable hand control by mental activity.
Given the right kinds of information and the right kinds of devices that are useful for the animal or for humans, the brain can start to adapt.
With practice, the brain can learn to do something it's never done before. By control, the prosthetic is not familiar with. But the key is to understand how these neural networks communicate between the brain and the body.
So if you're able to understand brain better, then you're also able to build better brain-computer interfaces because then they can use those signals that are responsible for different kinds of movements.
As Rao continues to collaborate with engineers, neuroscientists, and neurosurgeons to develop more BCI devices, he is working toward a future where the brain and technology come together seamlessly.
So this is one video, and there are some more videos which are really good. I would suggest you to, now looking at this video. It's really good video and it really get interested to the topic of PCI. So maybe I don't have enough time for showing this video right now. So let's just go to the next topic, which is robotics attempt. So when you come into robotics attempt, a computer can be accurate and it does not need any skill, and it can give some more precise output, give a better output compared to humans. So we can use the same robots or use the same technology for medical field also. So maybe you can perform surgeries, you can even perform stitching, any operations related to, let's say, medical care. So a machine can do it very well. And even we can even have some, people who are handicapped. Maybe we can even create bionic arms or bionic legs for them. So even still this research field, and still people are working on it to make it a more better output. But still we have some good outputs or good processes out there. And we have artificial kidneys, we have artificial hearts right now. And there are many such things that can help, with computer and technology and biology come together, they can really make some great outputs. And last is speech. I think I need not explain much about speech, but because we all know we have Siri, we have Google Assistant. So what does it do? Whatever we talk, it will be recorded and it will be converted to text. The same text will be processed by a computer, and the computer starts to operate based on it. So this is about speech. So this is all about biometrics. Now let me call Gaurav to speak about the last one, which is robotics.
Good morning. Now I'm going to tell you about robotics. So, where do we use robotics in real life? Are there any specific applications for robotics? Yes, there are applications for robotics. If you see in a factory, you see a robotic hand assembling all the components onto the assembly line. This is one of the best examples for robotics. These are created to accomplish tasks that cannot be performed by humans. But humans can perform those activities, but the robots which are designed can perform those activities very effectively. And robot can do a job very so for example, lifting a load of 100 kilos or something like that. So we have seen some robot in the movies like Star Wars. In Star Wars, we saw a robot like R2D2, or if you see Transformers, we see a car which turns into a robot. And in the movie Wall-E. And this can be somewhat over-exaggerated concepts like there aren't robots like that in real life, but these are the movies if you are really fascinated by robots, these are some of the movies recommended to watch. Now, if you go into hardware of robotics, there are sensors, actuators, power supply, body, and processor. Why do we need all those in a robot? A robot does not have eyes or legs to move, but we need to give something, right? So sensors provide a stimulus, like how we get a stimulus when we touch something. So sensors give that to a robot. You can see actuators are also using what is an actuator? Suppose if we move an arm, right? But a robot cannot move an arm by its own. An actuator is something a robot moves the arm. It is a device that can be considered to be a robot. Like it is in the frame of the robot. These are the components that are responsible for movement, and these components are made up of motors and receive signals from the control system. So what is control system? The control system is the main unit of the robot, which controls all the actuators and body. It is control systems are programmed to tell how to move a robot and how to use and take depending on the input from the sensors. Then these are kind of like a human brain. They send signals to actuators and other moving parts of the robot and receive signals from the sensors. processor. Processor is a part of a control system. Like it is there in a control processor. All the computing is done in all the computing of the control system is done by a processor. Like how the inputs must be processed and what are the different, then how to give an output depending on the input. These are all really computed in the processor. Now let's see power supply. This is the most important part of a robot because without power, the robot cannot move on its own. It needs power because the actuators, sensors are all operated on power. So we need this power supply. So these are the part. These are the hardware related stuff of robotics. Now let's go. Now let's see where to see. Like we can't make a real robot, right? Suppose if you want to make a robotic hand which can lift up 200 kilos, you can't make it in real life. Like if you don't have a team of some people or you don't work in a company, you can't make it in real life, right? So there is a simulation system called robotic operating system. It is all the algorithms in the ROS can be written in Python or C++. You can create a model which can lift up to 200 kilos in ROS and simulate it, whether if it is working or not working. And this simulation software can also be used in navigation, simulating navigation or mapping or path plan. Now let's see some of the applications where we see the robot. Have you ever heard of the company Boston? It is one of the best robotic companies. You see a dog-like robot which is there on the on the top right. This is a robot which is produced by Boston. It was the first kind. It can move on its own. It can detect obstacles. It can lift up to 150 kilos. And one of the most important application in agriculture is you can load a fertilizer onto a drone and move the drone all over the field and fertilize it. So it makes our lives easier. There are many applications in the field of robotic, in the field of medical also. Example at Avanci surgical system, which Mara will play a video on. Mara, can you play that clinical system?
So, thank you everyone. So that's our webinar.
I can't even walk properly from my work. I can't even stand properly from my work. But I lost my food walking every day.
Thank you everyone. So that's the webinar. So now we have, if there are any questions, we are ready to answer it. You can drop it in the chat box, or you can just ask question, raise your hands. So, are there any questions? Anyone? What's the lifelong news about coding? Just okay, let's just so now when you're going for engineering, or when you're whichever technology you're seeing in future, there will be even about if you're developing CPUs, or if you're developing any other related CPU, that will definitely need a use of coding, even for DLSI designs, or if you're using anything. Okay, let me tell you something. So normally coding will be like the future of HR use in So I don't really like any development just not like DLSI or gaming even if you're CPU like coding is important. So we coding just like normally even your mathematics skills improve as you already told in the PPT. Other mathematics skills to part two, we product like efficient output. So in that means coding is used openly. That's what the importance of coding is there. Future even coding has a really much importance. Whether it is software or hardware. Hardware side coding important. Now whichever IoT, robotics, whichever fields we discussed. Unlike fields robotics, coding, why use it? So, you can have questions, ma'am. Okay. So, once again, so normally robots are just an idiot.
Yes, sir. Basic aspects and then first మన క్లారిటీ ఉండాలి. చాలా అప్లికేషన్స్ ఉన్నాయి రోబోట్స్ కి. ఇప్పుడు దేనికోసం చేస్తున్నామంటే ఆ రోబోట్ నడిచే రోబోట్ కాకుండా కార్ లాగా ఉండాలి. సో మనం దేనికోసం రోబోట్ చేస్తున్నామో ఆ గోల్ క్లియర్ ఉండాలి. ఇంకా తర్వాత మనకు కావాల్సింది మెయిన్ ఏంటంటే పవర్ సప్లై చూసుకోవాలి. తక్కువ పవర్ తో ఎక్కువ రన్ అయ్యేటట్టు కూడా చూసుకోవాలి. మనం మెయిన్ ఆస్పెక్ట్ చూసుకోవాలి. ఇంకా దాన్ని ఇంప్లిమెంట్ చేసే ముందు మనం ఆ రోబోట్ని సిమ్యులేట్ చేసి ఒక ప్రోడక్ట్ లాగా చూపించొచ్చా లేదా కూడా చూడాలి. అలా
So, thank you everyone. Mainly principal sir, Ravindra Surki, and all the teachers who made it possible for this event, and all the students too who are being basic with us and who have been really an encouraging support for us. We would like to Thank you all. Thanks for attending my webinar. Thank you everyone. Thank you teachers.
Thank you. Thank you.
Thank you sir. Thank you everyone.
Thank you.